Okay, squad, we're taking a big leap forward today into the land of the abstract. Today, I want to teach you how to represent abstract functions with ordered pairs and graphs. Make this the title on your next page in your math notebook. When you've done that, mark that page, close it up, clear those distractions, maximize that brain power, and here we go. So, when we've been dealing with relations for quite some time now, and we've always called the quantities x and y, but they've also always kind of represented something that we're looking at, right? Like this relation shows the relationship between gallons and minutes. We've still been calling minutes x because it's on the x-axis and y, but it's always represented something. Or here, we've called number of toppings x and the cost of the toppings y. So we call things x and y, but they've always represented something. Or they've been mules and bales of hay, or they've y. We've always had x and y represent something what we call concrete, like water or mules or costs. And starting today, lots of the relations we look at are just going to be x and y, and we're not going to worry about what they stand for, distance from home and time, or number of tickets and cost, or anything like that. We're just going to call them x and y. These are called abstract relations. They show how two quantities, two variables are related, but without it necessarily. So as we do this, so this is like an example of that is here. Like we're just going to start looking at relations that are x and y, and what is y? Is it distance? Is it time? Is it cost? I don't know. What is x? Is it distance? Is it time? Is it cost? I don't know. We're not going to talk about them representing a certain thing. So as we do this, we're going to make three kind of main changes to what we've been doing. First, when we make ordered pairs from an equation like this, we're going to call x the input variable and y the output variable. So we've always kind of known what they were, right? X is hours, y is distance. That's kind of going away now. We're saying x is something and y is something, and it's not necessarily important what. So we're going to often call x the input variable and y the output variable, because in a moment, when I pick some numbers here to make ordered pairs, I'm going to input what I choose the x to be and see what I output the y to be. That's why they're called that. So x we're going to call the input variable, y we're going to call the output variable. That's our first change. 2, we're going to choose easy positive and negative values for x now. So now as we move into abstract, rather than me always just picking like 0, 1, 2, 3, those are still great, and I am still going to pick them. But I'm also going to start looking at negative inputs, negative choices for x as well. So rather than 0, 1, 2, I'll do 0, 1, 2, and I'll probably also do -1 and -2 pretty often. Like that. So that's the second change. So first change, we're going to call x input and y output. Second, as we choose ordered pairs here, we're going to use negative values and positive values. And 3, because we're choosing positive and negative values now, instead of only picking the positive numbers on the graph, we're going to be using all 4 quadrants on the graph too, so that we can go positive, positive, or negative, or negative. So that's our third change. Oh, this should say 3. So we're going to use all 4 quadrants on the coordinate plane. So now I'm kind of ready to go. So here's my equation. I don't know what y is. I don't know what x is. It's a relation between two quantities, but it's not important. So as I said, I'm going to choose the following inputs and outputs, or following inputs. And we call x the input variable because that's literally what we do with it. Like if I start with 2, I'm just going to input it into x in the equation and see what I get out for y. So in this case, if x equals 2, 2 to the second power is 4, so I would output 4 for y. So one ordered pair is 2, 4. Sorry, my tablet's dying here. Okay. and keep going. I'm going to maybe work my way back. So if x equals 1, if I input 1 in for x, then I'm looking at what is 1 squared, 1 to the second power. 1 times 1 is 1. So if I input x is 1, I output y is 1. Let's do 0 next. If I input 0 in for x in the equation, 0 to the second power is 0 times 0 is 0. Negative 1. Be careful with negatives. We haven't looked at negatives in quite some time, so make sure you remember how they work. So if I input negative 1 for x, negative 1 squared, that is negative 1 times negative 1, which is positive 1. And if I input negative 2 for x, then negative 2 times negative 2 is positive 4. So now I've got my ordered pairs, negative 2, 4. Remember, I can also write ordered pairs like this. Those are what I'm looking for in the graph. And here I go. Negative 2, 4. Remember, we do x first, then y. So negative 2, 4 is there. Negative 1, 1 is there. 0, 0 is there. 1, 1 is there. And 2, 4 is there. So I get a graph that's kind of shaped like a U. It's not linear, you'll notice. And I would like to continue it, like if I kept going, it would probably look something like that. We're not going to worry about verbal descriptions today. I just like to leave that so you see it. And that is what this equation looks like as a graph. It looks like that. I'm going to do one more just to kind of give you the hang of this before we do one together, or two together, I think. So remember, 3 things we're going to do. So here's my equation. I'm going to call x my input variable, y my output variable. Notice I don't know what x is. Is it hours? Is it minutes? Is it tickets? Is it years? I don't know. We're not worried about that today. We're just calling these abstract functions. It's just how 2 variables are related, x and y, whatever they may be. And they're related by this equation, 2x minus 3. So the second thing I encouraged today was, rather than just picking 0, 1, 2, 3, those are great, but we also need to start using negative values for x as well, and we may get out negative values for y. We did not get out any negative values for y last time, but sometimes you will. All right, so now I start inputting. So x is my input variable. We call it that because I'm going to input 2 in for x, and I'm going to see what that outputs for y. That's kind of what I'm doing. So if x equals 2, 2 times 2 is 4. Remember, I multiply before I subtract. 2 times 2 is 4. Minus 3 would make y equal 1. So 2, 1. Sometimes I erase these, sometimes I don't. Sometimes I just keep going. All right, let's do 1. 2 times 1. If I input 1 for x, 2 times 1 is 2. Minus 3 is negative 1. 2 minus 3 is negative 1. Input 0. 2 times 0 is 0. Minus 3 is outputs negative 3. Some erasing here so I'm not too sloppy. Now I've got to really do some concentration here because I'm going to have a bunch of negatives come up. 2 times negative 1 is negative 2 minus 3. How we did this, we never did negative 2 minus 3. We always did, when we subtracted, we did add the opposite, and that seems safest. Negative 2 plus negative 3 is negative 5. And if x equals negative 2, 2 times negative 2 is negative 4. Yeah, it's too sloppy. Negative 4 minus 3, or add the opposite, plus negative 3 is negative 7. So those are my ordered pairs now. And because I have so many negatives, when we do this as a graph now, we're going to have the positive and the negative parts of the graph all available to us. So here we go. I'm looking first for negative 2. Negative 1, 2, 3, 4, 5, 6, 7 is there. Negative 1, negative 5 is there. 0, negative 3 is there. 1, negative 1 is there, and 2, 1 is there. So now it looks like I've got a linear graph, and I can extend it past the points I have, and there it is. So that relation, 2x minus 3 equals y, would look like that on a graph, and would look like that with ordered pairs. All right, I may have to pause a lot because I don't have a ton of time left, but I'd like to do two together, one that's linear and one that's not. So first thing, if you'll pause and set up, here are the three things that are going to be different today. And pause and set up your page and unpause when you're ready to go. All right, so I'm going to input those same values, 0, 1, 2, negative 1, and negative 2. And you notice I've been starting at positive 2 and working back. The math is easier often with positive numbers. So I kind of like to start there to kind of get myself going. So if I input 2 in for x, 2 to the second power is what I'm looking for. That's 2 times 2 is 4. If I input 1 for x, 2 to the first power is 2. If I input 0 for x, do you remember? 2 to the power of 0. Do you remember what that is? Been a little bit. Anything to the power of 0 is 1. So you'll notice with this exponents, we divide. If I put in negative 1, this is super tricky. 2 to the power of negative 1, if you don't remember, is 1/2, positive 1/2. And 2 to the power of negative 2 is positive 1/4. We haven't done exponents in quite some time, so that may be hard to remember. So those are the points I'm going to put on my graph. 2, 4, 1, 2, 0, 1, negative 1, 1/2, and negative 2, 1/4. Yeah, and that function looks kind of like this. It's called an exponential function. Makes a cool curve. If you go back, it keeps getting closer and closer to 0, which is really hard to draw, but it doesn't touch it. It kind of starts following that because these numbers just get smaller and smaller, 1/8, 1/16, 1/32, and so on. All right, real fast, let's do one more. So go ahead and pause and set up again. I want to do a linear one as well. I'm going to probably have to ask you to pause a lot because I have to, I'm down to about 2 minutes for this one. All right, here come my inputs. And away we go. If I input 2 here, negative 2 times 2 is negative 4, plus 1 is negative 3 is going to be my output, negative 3 here. If I input 1 for x, negative 2 times 1 is negative 2, plus 1 is negative 1. Erase and start again. If I input 0, 2 times 0 is 0, or negative 2 times 0 is 0, plus 1 is 1. If I input 1, negative 2 times, negative 1, I'm up to. Negative 2 times negative 1, weirdly, is positive 2, plus 1 is 3. And negative 2, if I input negative 2, negative 2 times negative 2 is 4, plus 1 is 5. So those are my ordered pairs. If you want to go ahead and pause and write those in, you can. I'm going to have to graph them real fast. Negative 2, positive 5 is there. Negative 1, positive 3 is there. 0, 1 is there. 1, negative 1 is there. And 2, negative 3 is there. And it is a linear graph that looks like that. So there you go. So this equation here, y equals negative 2x plus 1, that's its graph. Those are its ordered pairs. I am out of time. Hope this went great for you today. If not, give it another look, and we'll continue and finish it up tomorrow.